In this example, we want to solve negative 2 is less than or equal to x plus 3 is less than or equal to 0. And this is a compound inequality. What this really means, this is really 2 for the price of 1, right? We're really saying negative 2 is less than or equal to x plus 3, and, right, this is technically an and statement, x plus 3 is less than or equal to 0. But who wants to write all of that every time, right? That's way too much writing. So we combine these into this compound inequality. We can call this a nested inequality, and solve it all at once. The way you solve these is to perform operations on all three sides at the same time, the left, the middle, and the right. So here we're trying to isolate x in the middle here. So I'm going to subtract 3 from all three sides at once. Look at that. Okay, so that leaves us with negative 5 is less than or equal to x is less than or equal to negative 3. Okay, and that's our solution. We don't want to represent it in this form. We can do it in a graph notation or interval notation. Let's do it in graph notation just to get an idea of what these will look like, and then we'll do an interval. So this is all the x values nested between negative 5 and negative 3. So on the graph, say it was 0 is up here, maybe negative 3 is about here, negative 5 is about here. We are talking about all the values between negative 5 and negative 3, and we're including the endpoints because we have this equals to sign attached to our inequality. So here I'm going to use a hard bracket. There we go. All right, from negative 5 to negative 3 and everything in between. If there wasn't an equal sign here, I would use a soft bracket, also known as a parentheses. Okay, in interval notation is just a representation of what the graph says. So what the interval notation is saying is I start at negative 5, I include negative 5, that's why I have the hard bracket. The comma means I have everything in between, and then I stop at negative 3, again with the hard bracket. There's the interval notation and the graph notation. Let's try another one. Here we have negative 2 less than 1/2 x minus 5 less than 1. Again, we want to work our way in towards x by doing the same operations to all three sides at once, sides in quotes, the left, the middle, and the right. So let's see, working our way in towards x, first thing we want to do is add 5 to all three. All right, plus 5. That gives us 3 less than 1/2 x less than 6. Okay, we're still trying to get that x by itself. So now I'm going to multiply all three sides by 2 to get rid of that 1/2. Okay, so 2 here, 2 gets rid of the 1/2, and 2 over here, giving us a final inequality of 6 less than x less than 12. So we have all the x values between 6 and 12. Let's just go straight to the interval notation. I'm using the parentheses now because we don't have an equal sign here. We start at 6, we have all the stuff in the middle, that's what the comma represents, and we stop at 12. You can think of this interval notation as where do we start, comma, where do we stop. All right, so there's our interval notation there. Okay, let's try another one. Here we have negative 4 less than or equal to 2x plus 5 all divided by 3 less than or equal to 1. We want to solve this compound inequality. Again, we work our way in towards that x in the middle by getting rid of everything around it, essentially. We have this 3 on the bottom here, so let's multiply all three sides by 3 first. Okay, that gives us negative 12 less than or equal to negative 2x plus 5 less than or equal to 3. Again, we're working our way in towards x. So next I'm going to subtract 5 from all three sides. Okay, so negative 17 less than or equal to negative 2x less than or equal to negative 2. And finally, we want to divide all three sides by negative 2. But now we have divided across an inequality by a negative. Anytime you multiply or divide across an inequality by a negative, you need to change the direction of the inequality, right? So this is an alert, right? Because we did this with a negative, we have to change the directions of these. Okay, so now we actually have 17 halves greater than or equal to x greater than or equal to 1. It's a good idea to rewrite inequalities like this so they're in ascending order when they go from left to right, just to be consistent with how we're going to write the answer. So anytime I get something like this, I always rewrite it. So we can rewrite this as 1 less than or equal to x less than or equal to 17 halves. And now we're back on solid ground. We can recognize what this looks like going in order from less on the left to more on the right. All right, and then we can go straight to our interval notation on this one. I'm using the hard brackets because of the equal sign. We start with 1, then we have all the stuff in the middle, and we end at 17 halves. And again with the hard brackets because it has an equal sign attached to the inequality. There we go. 1 up to 17 halves.